G'day. This is the subject of today's video. It's, as you can see, a wheelchair, and I've been asked if I can make it narrower, and this is part of the volunteer work I do with Technology for Aging and Disability. The short answer is yes, but at the same time it's one of those jobs that I don't really want to do because it's a bit on the awkward side, but sometimes, you know, you have to do what you have to do. So it's basically a steel tube frame, and I'm going to show you a few tricks as to how you can do that sort of thing without necessarily causing any great problems. Most of you probably aren't familiar with wheelchairs. I know before I started doing this thing I wasn't, and you know, you might think of them just as basically as a chair on wheels. This one, and they're usually a lot more sophisticated than that, depending on the needs of the person using them. This one's got a couple of features. The backrest is adjustable from the hand grips on the back, so you can adjust the angle of that. You can also adjust with this device the rotation of the seat, and that's to relieve pressure on the people who are sitting them, so that you don't get sores developing because they're always sitting on a thing. So you rotate them back a little bit, and that relieves some pressure. This one's also got hand brakes on the wheels here. Sorry, can't quite see that, I'm in the wrong spot, but take my word for it, there's hand brakes on the wheels, as well as some brakes here. Now, what I need to do is basically take 70 millimeters out of each of these tubes. However, this one has got the seat tilt feature on it, and so I'm going to have to make two cuts there and take out 35 millimeters on each. The other problem I've got is these links here. They're the ones that rotate the seat back and forth, and so I'm going to have to shorten these bosses by about 35 millimeters, and that's going to make those a bit awkward too. So it's not just a simple, you know, one cut, put it together, weld it up. It's going to be a lot more than that. Before I start even cutting, one of the first things I've done here is I've put some marks on the frame. From there to there is 350 millimeters, and I've done that for all three members, and that's so if I cut it, I can get it to line up. You can imagine if I'm a bit haphazard with my cutting, instead of having two wheels that are parallel, I could have them so they're toe in or toe out. So that's to try and help me get that lined up. There's also another line here which you might or might not be able to see. This bracket has got some angular importance. If I have it in the wrong spot, the thing won't adjust. So what I've done there is I've put a line across there so that when I cut there and there and join these together, I can line these up so this bracket will be in around about the same position. So the start is basically preparation, making sure you've got a reference framework so you're not putting things back in the wrong spot. I have my frame stripped down almost as far as I probably want to go. I could take off the wheel hubs and the lifting brackets and the brakes and the wheelie bars, but perhaps the wheelie bars because they're plastic and when I weld they may melt, but I work on the basis that the less I take off, the less I've got to put back on and possibly put in the wrong spot. So that's going to do me. Now, two things here. One is that those pivots run on a bit of steel bar on a shoulder bolt, and we talked about shoulder bolts before, but that shoulder bolt is actually recessed into here. So what I'm going to have to do, I think, is once I've cut this, put it up on the mill, cut those off, drill for the thread on the end of the shoulder bolt, and then I'm going to have to counter drill that. I'll probably just counter drill given the size of the shoulder versus the thread, so that I can get that back in there to where it should be. These have also been put in with Loctite, and that took quite an effort to get them off. I had to get a cheater bar on the end of the hex key to get it. So I have to remember to put Loctite back on them when I put them back on. Now I'm going to be cutting these tubes next, and two things there. One is that I could cut you know, all down the middle, except that then gives me a nice weak spot right down. So what I'll probably end up doing, these two I'll cut, you know, there somewhere, and this one, you know, I'll find a spot maybe there, and then this one over here, so that I've got the cuts staggered a little bit. Whether that really matters, I'm not sure, but it makes me feel better doing it that way, so that's what I'm going to do. To get a nice round cut, what I'm going to do is get a bit of paper and wrap it around the tube, and because the paper's got a straight edge on it, if I get it so that the paper ends and where it, you know, is a nice circle, that gives me a straight line through there. So I'll then come along and mark that with a texter, and that'll give me a cut line, and for these two that'll be 70 millimeters apart, and for these two it'll be 35. Once I've done that, I can then put that up on the mill, slice these off. When I go to weld these tubes together, I want to make sure they're aligned properly. Now, I should have a reasonably square cut, although as you can see there, there's a little bit of a gap. You'll expect that. Angle grinders are not as precise as we'd like them to be. Previously, when I would have done that, I would have got a bit of angle like that, nested everything in, and used that, clamped in there, and used that as a guide. Okay. However, there is another way of doing it, and that's using a bit of tube. Now this is a bit of 22, nominal 22 tube, and this is a nominal 25 OD tube with a sort of a 1.5 wall thickness, so that should almost fit inside. It does, not quite. So what I'm going to do is, using the angle grinder, very carefully slit up the length of that, so that I can, and hopefully there'll be a little bit of spring in that, and so I can put that inside each of the tubes, and that'll align it. Now, if I get my, where's the seam? There's the seam there. If I put my cut on the seam, for example, and that's just so that you know where it is, and I have that so that that is, the bending is that way, having the seam on what's called the neutral axis helps. Okay, if I have it down there, there's all sorts of stress that is going to occur there, and it's not going to like it because it's not continuous. Neutral axis, not a problem. So if I put that in there and there, it does a couple of things for me. One is it straightens the tube up, aligns it all for me. Secondly, it adds as some reinforcing in there. And the third thing it does is acts as a backing piece for my welding, so I can weld around there and run slightly hotter than I would otherwise perhaps do for fear of melting through, knowing that I've got a little bit of tube behind there that will help control that. So, you know, all up I'll have something like a 3mm thick piece of steel that I'm welding, so that'll all be good. So the next task is to slit these bits of tube. I'll probably grab it with the vice grips there, slit away, and then turn it round and just do the last bit there. Here I am, ready to, well, drill a machine. I've cut the frame in half, and as I thought, this just clears, so that's all good. What I'm doing is drilling my tapping drill size down to the bottom here. It actually needs to go halfway through the plate here. I'll then come in with my counter drill and drill that down, and then finally I'll come along with a cutter and lop that off at the right side. In fact, I might do it, drill that down, lop that, then counter drill. That's probably a more sensible way of doing it. The reason I want to do this is I want to try and pick up on the existing hole rather than cutting that off and having an iffy sort of location. The drill I'm going to be using for counter drilling is this one. I had to whip down to the hardware shop and buy this. This is what's a reduced shank drill, or sometimes called a blacksmith drill. I don't like them terribly much myself, because once you start getting up in size, the amount of torque that you're relying on a drill chuck to handle starts getting a bit silly. So not all that keen on them, but in this case I needed a short drill to get in here, and this is about the best I could do. I'm using the collet chuck because the drill chuck takes up an extra bit of Z, and I haven't got that. So it's really just a matter of drill, lop, counter bore, repeat down here, and then put up the other one, do that. Once I've got those done, it then becomes easy. I can get my bits of split tube, I can clean up the ends here, and basically weld everything back together again. A couple of things I meant to mention about this setup. First of all, I've got some paper here, and that's purely to save showering swarf all over the brake assembly. I'll check that before I put it all back together again, but I'm hoping that that'll help keep it clean. As you can see from all the swarf down here, there has been some thrown up. There's a lot of blue stuff too, which probably means that blue Loctite was used. I had a lot of trouble getting these bolts out, so important hint for putting it all back together again. Last of all, these are some extended parallels that I picked up at a car boot sale, and they're dated June 54 with CF on them. So thank you to CF, whoever they are, they're getting good use. It's another one of those bits of kit that I don't use all that often, but every so often just comes in handy. In this particular case, it means that I don't have to take the, what would you call it, the handbrake lever off. I can leave that there without having to worry about interference with the table and all that sort of thing. Trying to put all this lot together. I've got my split tubes, and to get them in, I've compressed them with a lot of the vice grips and then hammered them in. So they're a snug fit, which is actually good. I probably could have taken a little bit more out of the slot there in hindsight, but that's okay. So I've now got that to be put on, and then the other half of the frame, and then I can start welding up the seams. So really the prep work has taken a lot of the time. Most of it is, you know, drilling things out, tapping things, all that sort of stuff, making up the tubes. The actual putting together shouldn't take, the actual welding together shouldn't take too long at all. Here's the frame together. Much banging, thumping, clamping, cursing, all that sort of stuff to get it together. I did have those slots a little bit tight, and so I went in with an angle grinder to just relieve those a little bit. But measuring across my marks here, I'm getting 380, which 450 take 70 is 380. So that's all right, and that's all right, and this is all right. So all I need to do now is basically weld these up, throw a bit of paint on, and back onto the chair. So there you go, wheelchair modifications or frame modifications when you've got round tube. Thanks for watching, hope it's been of interest. See you for the next one.